Final section in Unit 6, we're talking about real-world data. So just a quick refresher on something we looked at in the last section with composition and inverses. We've got two functions here, f of x equals 3x minus 1 and g of x equals 1/3 x plus 1. And we're asked to determine by composition if they are inverses. So let's start off by doing, I'm going to color code this. Let's do f of g of x. I'm going to start, f of x is going to be red, g of x is going to be blue. So with that, we're going to do f of g of x. In other words, we're going to replace the x in f of x with all of g of x. So we're going to replace the x's with 1/3 x plus 1. So f of x used to be 3 times x. Now it's going to be 3 times 1/3 x plus 1. Let me close that parenthesis off with the red. And then we still have the minus 1 from f of x. Now when we distribute that 3 to both of those, we ended up with x plus 3 minus 1, which when we clean that up, we end up with x plus 2. Remember, we want it to be just x all by itself. So this is not, sorry, let me clarify that. As a result, we can say f of x and g of x are not inverses of each other. If you find out one direction doesn't work, you don't need to check the other direction. We don't need to check out g of f of x because if one doesn't work, the other doesn't work. All right, so for this section, we're going to do a quick refresher on linear, quadratic, exponential, and also square roots. So linears are lines. They're super exciting. Their parent function is f of x equals x. The constant first differences between y values as long as you have evenly spaced x values. For quadratics, similar, except for this time it's x squared. We got a parabola there, and they have constant second differences between your y values. Exponential functions have constant ratios between our y values, and square roots have constant second differences between our x values for evenly spaced y values. So just a quick refresher on that. Let's try this out. We've got time and height of, I'm going to say it's a plant. After 25 years, it's 198 inches, not super tall. But using constant differences, okay, double check, are the x values evenly spaced? If so, go for it. Yes, they're evenly spaced. They're spaced out by 5. So looking at our y values, we're going to go 58 to 93, that's plus 35. From 93 to 128, that's plus 35. From 128 to 163, that's plus 35. From 163 to 198, bet you can't guess it, it's 135. So those are our first differences. They are constant. So the first differences are constant, and therefore it is a linear graph. So again, first differences are representing linear. Now this next one, our x's are evenly spaced, no problem there. Our y values, let's take a look at the differences here. So our y values, this goes down by 400. This goes down by 384. Going from 9216 to 8847, that's down 369. And from 8847 to 8493, that's going down by 354. Now, not linear, all different numbers there. Going from negative 400 to negative 384, that's plus 16. From negative 384 to negative 369, that's plus 15. From negative 369 to negative 354, that's plus 15 as well. Now, folks, those aren't all exactly alike, but they're pretty darn similar. So what we're going to say is that they are quadratic-ish. It's fairly close to being a quadratic function. Okay, well, what if there's a slightly better option? One option we haven't checked out, we've just been looking at first and second differences. We can also check out the ratios. So if we do 9600, take one y value divided by the previous y value, we're going to get 0.96. If we do the same thing over here, if we do 9216 divided by the previous y value of 9600, it ends up being 0.96. Now from here, this is where things are going to vary a little bit. If we do 8847 divided by 9216, it's not exactly .96, but it's approximately 0.96. It ends up being 0.9599, which is pretty darn good. That's 0.96. And here, again, we'll do the same one more time. 8493 divided by 8847. And that also, if you round to two decimal places, is about 0.96. So maybe exponential would be an even better option.